Hello, my name is Matt Rains, and I am making the video for part 1 of Lab 3 for Group 1. For the first step, we're going to get the points of the airfoil to model it in SolidWorks. So I chose the NACA 0018 because that has the maximum thickness as 18% of the chord length. So based on the simulation data, for the blockage ratio, we're going to have the airfoil have a chord length of 15.24 millimeters or 1.524 centimeters. So I'm going to enter that in here. Everything else should be good. We're going to click download CSV file of coordinates and then just save that here. Next, you're going to open up the CSV file that you just downloaded. And then go to airfoil surface. Take these points, copy them, and then you can close this file. And then you're going to go into a new file here, and then you'd paste the points here and then add a row of zeros. So as you can see, I've already created the file of points. The next thing you want to do is to just copy all these and then put them into a text file, which I have done here. After that, we're going to open SolidWorks. So now we're going to go into SolidWorks. First thing we do is we're going to go to curves, curve through XYZ points, and then we're going to select our text file and then just click OK, and it should appear here. We're going to go to the front plane sketch, and then we're going to select our curve and then click convert entities. You should see this outline appear now. Now we're going to come over here. We have to connect our airfoil, so if we just use a straight line here, it should appear to be solid now. So click that, and then we can just go to insert surface planar current sketch, and here we go. So this should be good. So now if we want, we can save this, and then for ANSYS we're going to save it as an IGES file. So now we can close this and open up ANSYS. Okay, so now we have ANSYS open. We are going to create a new fluid flow project. First thing we're going to do here is I'm going to click and then change analysis type to 2D. And then I'm going to right click, new design modeler geometry. Wait for this to open. Okay, so we're going to go to File, Import External Geometry File, and then the first thing we want to do is import the wind tunnel, and then we click Generate. Perfect. Now what we're going to do is go to File, Import, and then we're going to use the airfoil model that we just made. And then now that we have both of them, we're going to create a Boolean and then subtract, and we're going to select the the wind tunnel for the target body and then the airfoil for the tool. So we're going to be subtracting, as you can see, the airfoil from the wind tunnel, just like this. Okay. Oops. So once you do that, you're good. You can close Design Modeler. And then we can go into Mesh here. Here we go. Let this load. And then our model should be all here. Yep. So first thing we're going to do is we're going to create named selection. So we're going to go to Edge, click on our inlet, right click, and then create name selection. We're going to name this velocity inlet. We're going to name our outlet. And then we're going to name our walls. And then we're going to go here and then select our airfoil. We're going to name this airfoil. And we should be able to check here. Oops, sorry. Name selections. We have velocity inlet, outlet, walls, airfoil. Perfect. Now we're going to go to meshing. Method. We're going to select this geometry here. Go to triangles. And then we're going to go to sizing. And then same thing, geometry. And then element size, we're going to be 0.005. And then we click generate. And our mesh should be good. Yep. So you can see our airfoil is here and our mesh is looking good. We're going to click close meshing. And then update. Perfect. Now we're going to go into setup here. And then double precision to processes. We should have it to be 2D. And then start. Okay, looks like we're ready. First thing we're going to go is to models. We can go ahead and turn energy on. And then going to here, change this to K epsilon, enhanced wall treatment, and then pressure and thermal effects. And there should be good for that. And then we can double check that our fluid is air. Density is all that. Yep. So all this should be good. We're going to go to boundary conditions, inlet, velocity inlet. And then if we go to the data here, then for the inlet at 60 Hertz, we should have it be 4.7 or so. So we can go ahead and enter that. Apply. Close. And then if we want, we can double check the walls and all that to no slip stationary, right? So that's perfect. Next, we're going to go to reference values, compute from velocity inlet, surface body. Our velocity should now be set to whatever we put earlier. And then if we want to double check our methods, second order upwind, first order, perfect. And then we're going to go to initialization now. We should be good. Initialize. And then calculation. And we can do, let's say, 150 iterations. And then calculate. And then we're going to go ahead and let that run. Perfect. So now we're done with that. So we can either create the plots in here, or what I like to do is go into results. So now what we can do is, oops, sorry, here. So first thing we're going to do is contours. We're going to do our pressure contour. And then we're going to do symmetry 1. I like to do 110 and apply. Perfect, that looks good. And then we're going to go to default legend view, change that to fixed. Perfect. So here's our pressure contour. As you can see around the airfoil, we have a big drop in pressure on the sides here, and then a bit of an increase here in the front where the air gets blocked up. Next thing we can do is insert streamlines. Same thing, symmetry 1, and we can do, say, 40. Apply. And then decheck our pressure. And then let's increase these actually to 60 maybe. So as you can see, we see our velocity streamlines through the wind tunnel. And you can see the air curves around the airfoil. Let's increase these more, let's say 200 maybe. Here we go. So yeah, we can see better now. Velocity going around the airfoil, right? Decelerating towards the back end, and then going back to free stream velocity. And then next thing we can do, go to vectors here, velocity vectors. Symmetry 1. And then velocity. And then we're going to re-click streamlines. So now we can see our velocity with vectors. Same thing as we zoom in, right? We can see the air curving over the airfoil, right? Decelerating towards the back, and then accelerating once again to free stream. So here's our vectors. If we want to find the free stream velocity to calculate the drag coefficient, then what we can do is go to probe, and then just somewhere in the text section here in front of the airfoil we can click, and then here's our velocity, right? It should be similar to the velocity that you inputted. After that we can go here, back to Fluent, report definitions, force report, drag, and make sure it's drag force, and then click the airfoil, compute. Here we go. So here's our drag force And then using our velocity from earlier, right, we have our drag force here, the velocity, and then using the formula force divided by dynamic pressure times the chord length times the span, we can get our drag coefficients. So that's the tutorial for part A of the simulation. Thank you.